right, guys, welcome back. All right, so this one's going to be a little bit different. I don't know if we quite did anything precisely like this in class while we were preparing, but this is one that just kind of tests your general transformational knowledge. We provided a graph on the right that could help you kind of like process and work these particular problems, although you don't really have to if you understand the nature of a translation. And so basically what they're saying is that they have this blue point A that goes from 10/8 to -3 comma -2, and that moved under a translation. Okay, so this is in other words is gonna have to do a slide. And so what they'd like us to do is to figure out where B would end up if it slides the same exact way. All right. So a couple different approaches. One approach we can take is completely graphical. Like we can just do this on the graph and figure it out. Because if we're going from A to A prime, we can just kind of like map out how much down and how much over we'd have to go. Okay? And so we can just count it. So we'd have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we have to go down 10. And then we have to go left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so we'd have to go -13 on the x direction, right? And so to kind of complete our thought about the slide, what this means is that we're sliding left 13 and then down 10. Well, we know how that goes. So left 13, down 10 means that the xy shall travel x minus 13, y minus 10. And so once we get it into this rule, we can just feed it the b point, and we can kind of do the same thing. And so if we know that b starts at 3 comma 7, at b, this says take the x value, which is 3, subtract 10. And then it says take the y value, which is 7, subtract 13. And then take this, that erased. Okay, minus 13, and take the y value, which is 7, subtract 10. Right? That means our b prime value shall be 3 minus 13, which is -10, and then 7 minus 10, which is -3, and then we can just simply graph that. Okay? And so we should graph that. So we go to -10 minus 3. It predicts that the b prime point shall be located here, -10 comma -3. Now we can also confirm that on the graph. We just have to travel the same way. So we have to drop 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then go over 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12. Look at that, 13. And so if we drop 10 and then 13 here, we end up with a b prime value, at 10 comma -3. And so again, like this is a little bit of a strange problem, but it's not outside the world that we've been living in. It's just we have to kind of think about how to use transformations a different way. Okay, here we have a reflection. Okay, so this is going to flip. So we should probably find out right away where it's flipping. And so we're flipping from A to A prime. So we're going from A to A prime. And so whatever we're flipping over has to be generally in the middle between those 2 points. And so if I count over 1, 2, 3, and count over this, that means our line of reflection is going to be the y-axis. Okay, so we're flipping over y-axis. And so now they're saying, hey, if you can flip the blue points, go ahead and flip the red ones the same way. So we're going to flip over the y-axis. Well, that's going to be 1, 2, 3 to the y-axis, and so we should travel 1, 2, 3 away from it. That's going to be our b prime point. Okay, in terms of coordinates, well, I know the x value is going to change to a -3. The y value stays a 7, and so we have b to be 3 comma 7. And again, we know that it's going to be reflection because we have that nice right angle, and then we have the same distance to the left and right, hence bisected by the line of symmetry. All right, moving on to, that's what I did not want to do. Okay, so moving on to example 3. Looks like we're asked to map another translation. Okay, so we know that we're sliding. So we should probably figure out how much we're sliding by. We're going from A to A prime. So here's A right here. And so we're going to go over 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12, 13, 14. So we're going 14 to the right. And it looks like we're going to go 3 down. And so we're sliding right 14 down negative 3. Okay. And so that translates to a rule. We're going to add 14 to the x and then take away 3 from the y. Okay, so if our B point starts at, where are we, 10 comma negative 3, we'll take our original 10, add 14 to it. Oh, that should be a negative 10. Ooh, that's a mistake. That should be a negative 10. That's a negative 10 right there. So it's negative 10 plus 3. So negative 10 plus 14. And we'll take our y value of negative 3. We'll take our y value negative 3 and then subtract 3 from it. And so our B prime point should be, let's see, that ends up being 4 comma 0. Okay, so 4 comma 0 should be here. Oh, I'm sorry, not 0. What am I thinking? Not 0. Negative 3 minus 3 is negative 6. Okay, so B prime isn't there. B prime is over 4, then down 1, 2, 3, 4, 5, 6. There's my B prime. Okay, so if we confirm by counting, we should go over 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then down 4, or down 3, excuse me, 1, 2, 3. And so we added 14, then dropped 3. And so B precisely is at 4 comma negative 6. Oh man, lots of mistakes there, guys. Sorry about that. Okay, and so again, a weird skill, but one that you have to demonstrate knowledge of. Why is my calendar popping up? Go away, calendar. One you have to demonstrate knowledge of. So like, if you know how one point was translated or reflected, you have to be able to translate and reflect other points as well. All right, so thank you.